All right, class, today we're studying section 10.1, which is the law of cosines. We are going to be able to use the law of cosines to determine the missing parts of a triangle. First, let's review some properties of triangles that you may have forgotten from geometry. First, the two smaller sides of a triangle must add up to be larger than the largest side of the triangle. Second, the largest side of the triangle is always opposite the largest angle of the triangle. And the same is true with the smallest. The smallest side has to be opposite of the smallest angle. And the third, which we have already used a fair amount, is that the sum of the interior angles of a triangle has to be 180 degrees. Up until this point, we've only used trigonometry with right triangles, but there are a few formulas that allow us to apply trigonometry to triangles that are not right. Pretty much all triangles will be labeled the same way. All of the angles will be indicated with capital letters. All of the sides will be indicated with lowercase letters. Side C will always be across from angle C. The same with side A. Side A will always be across from angle A. And side B will always be across from angle B. One formula that allows us to apply trigonometry to a triangle that is not right is the law of cosines. The law of cosines came about because in order to use right triangle trig, you have to create right triangles within your larger triangle. So the law of cosines deals with mostly your sides and only one angle. It stems from the Pythagorean theorem. We have the a squared, the b squared, and the c squared. B squared, which is a side, plus c squared, minus 2 times side B and side C, multiplied by the cosine of angle A. And these sides can be interchanged to be anything, but the key thing is the side that's by itself has to be across from the angle that's also, or has to be across from the angle that you're taking the cosine of. So in this case, angle A and side A are across from each other. You can use the law of cosines in several situations, but these are the two main ones. When you have two sides and an included angle, or when you have all sides. And let's do an example. For this particular triangle, I want to find all the angles and all the sides. And there are several ways which I can do this. Since this is not a right triangle, I cannot apply trigonometry directly, but I can apply the law of cosines. The first thing that I will end up finding is side AB, or we could name it with a little c, because it's across from angle C. Since I want to find angle C, or side C, C is going to be on the side by itself. And then I continue to follow the formula, 14 squared plus 10 squared minus 2 times 14 times 10 times the cosine of angle A, or in this case angle C, which is 60. And then I can apply my calculator. 14 squared plus 10 squared is 296. And then 2 times 14 times 10 is 280 times the cosine of 60. It is important to follow your order of operations here. It is easy to forget. The cosine of 60, you could use your calculator, but you should remember that it is 1/2. So I've got 296 minus 280 times 1/2. 280 divided by 2 is 140. And 296 minus 140 is 156. And 156 is not a perfect square when I square root both sides, but it does reduce to be 2 radical 39. So that's the measure of side C. Now I want to find one of the angles. In order to do that, I have to use the law of cosines again. It doesn't matter which one you try to find first. I'll find angle A. So I have A squared, which I know is 10, that has to be on the side by itself because angle A is the angle I'm trying to find, equals 14 squared plus 2 times the square root of 39 squared minus 2 times 14 times 2 root 39 times the cosine of angle A. My calculator will be in degrees because my first angle was given to me in degrees. Now I can apply some algebra. 14 squared plus the square, or 2 root 39 is 352. And then I have 2 times 14 times 2 root 39, which is 56 root 39, and then the cosine of A. So now I have to get the cosine by itself. 100 minus 352 would be negative 252. Then I'll divide both sides by 5 root 39, or 56 root 39. Which ends up being negative 3 root 39 over 26. Oops, positive. And then equals the cosine of A. And then I have to use my calculator. Since it's positive, I know my angles will either be in the first or the fourth quadrant. So the approximate angle is around 43.9 degrees. Both of these angles would technically measure 43.9 degrees. But remember, all of the angles inside of a triangle have to add up to be 180. So this angle here is going to be entirely too big. So angle A measures 43.9 degrees. Now that I know that angle A is 43.9 degrees, then I can figure out the third angle by just subtracting them from 180. So 180 minus 60 minus 43.9 is 76.1. And that would be angle B. And now I've solved this triangle. I found all the missing parts. We'll work with this more in class, so make sure that you write down any questions that you might have.